Hello everyone, welcome to the second half of the semester. We will now study influencer statistics. Some part of the video I will make some comments and others you will just read on your own. Let's quickly overview the influencer statistics. Suppose you are given a population with a population size n. You want to know the population mean. Dealing with the population is difficult because the population size is too large. So we will select a sample with a sample size n. Based on it, we can determine sample mean. So using sample mean, we want to estimate or make an educated guess about the population mean. This involves three processes: point estimate, interval estimate, hypothesis testing. These processes utilize the normal distribution with the central limit theorem that we studied in chapter 5.4. This example demonstrates the behavior of unbiased and biased estimators. On the left-hand side, you see a distribution of a population. Based on it, you can calculate population mean, median, range, variance, standard deviation, and proportion. You see those values listed on the left-hand side column. On the right-hand side is a distribution of a sample mean, that is, a sampling distribution. Using CLT or the central limit theorem, we can also calculate CLT mean, median, range, variance, standard deviation, and proportion. Those values are listed on the right-hand side column. When you compare those two sets of values, you notice that some do match, some do not. For example, CLT variance matches with the population variance. What that means is that CLT variance is good in estimating population mean, so it is an unbiased estimator. However, CLT standard deviation do not match with the population standard deviation. So this is not good in estimating population standard deviation because it is biased estimator. This graph shows that as the sample size gets smaller, t-distribution graph moves away from z-distribution graph. In other words, as the sample size gets smaller, we introduce more error in estimating interval. In terms of margin of error, previously margin of error on z-distribution was up to this point. However, when sample becomes smaller, now margin of error becomes much larger. Hence, the confidence interval becomes much wider when sample size becomes smaller.